welcome to thedeciphers.org. My name is Cordelia Kataria and I am a 9-year-old computing explorer and problem solver. I did my GCSEs when I was 8-year-old, and now I'm doing my A-levels.
I'm Isaac Tipler, an experienced maths teacher helping with the Deciphers.org and going to help deliver these A-level workshops. So Cordelia, tell us a little bit more about these workshops that we're doing.
That's looking good. So these workshops are going to be about maths, and we're going to do one every single week. And we're going to do it about different topics. Today's one is about sequences and series. Last week we did partial fractions.
Yep, so the last week's video is available for them to watch if they missed it. Is that right?
Yeah.
They can go on your YouTube channel and watch previous week's videos. Even if you don't watch it live, you can always go back and watch it. And how can people interact with these sessions?
So they can interact by typing something in the chat if they have any ideas about how to solve it. We've got some questions over here. This one, and got 5 questions. So, with sign line, let's start. So, definitions. Here are some important definitions prefacing the content in this chapter, even though it isn't a chapter. A sequence is increasing if each term is greater than the previous. So, for example, 4, then 9, then 14, then 19. A sequence is decreasing if it's less than the previous. So 5, 4, 3, 2, 1, blast off! Not including blast off, of course. A sequence is periodic if the terms repeat in a cycle. U of n plus k is U of n for some k, which is known as the order of the sequence. For example, -3, 1, -3, 1, -3, and then keep going. That's periodic with order 2. And order basically means that value of k. So how much it repeats. For example, this one, -3 and 1, they're the two ones that repeat. So for example, if we had another one like 2, 3, 1, 2, 3, 1, then it would be order 3 because there's 3 things that repeat. Right, now.
Good, excellent.
So now let's do arithmetic sequences. An arithmetic sequence is one where there's a common difference between each term. Arithmetic sequences are of the form a, then a plus d, then like a plus 2d, then a plus 3d. Then it keeps going like that, where a is the first term and d is the common difference. And the nth term of an arithmetic series is given by u of n is a plus n minus 1 times d.
And the important thing about that formula there is that you need to remember it because it's not given in the formula book. So there's lots of formulae with this topic, sequences and series. Some of them are given to you in the formula book, some of them aren't. A good way to remember it is that the UN formulas aren't given, but the SN formulas are. So this one is not given, so you need to remember.
So now let's do the arithmetic series. Arithmetic series is the sum of the terms in an arithmetic sequence. The sum of the first n terms in an arithmetic series is given by S of n is n divided by 2 times 2a plus n minus 1d. Or S of n is n into times a plus l. So a is the first term, d is the difference, and l is the last term. So basically what this means is, let's do the last one. Okay. Then n divided by 2 times a plus l, that's the number of terms. Okay, so that's divided by 2 equally. I think I should give an example.
But we'll do examples when we look at the questions. So that if we just concentrate on the notes, and then we'll come back to all of these in the questions that we've picked out to go through. So we'll have lots of time to see these formulas in practice.
Okay.
So just a note on which ones you're given. So you're given the n over 2 times 2a plus n minus 1d in the formula book. You're not given Sn equals n over 2a plus l, but those formulas are actually the same because l is un, where n is how many terms are in the sequence. It's the last term. So if you did a plus n minus 1d, a plus un, that's technically a plus l. So actually it's the same formula. It's just the 2a plus n minus 1d has been simplified.
Yep. So now let's do geometric sequences. So the defining feature of a geometric sequence is that you must multiply by a common ratio r to get from one term to the next. Geometric sequences are of the form a, ar squared, ar cubed, and then ar to the power of 4, where a is the first term in the sequence and r is the common ratio.
Brilliant.
So the nth term of a geometric sequence is given by u of n is a times r to the power of n minus 1.
Good. And do we need to remember that one, or is it in the formula book?
Okay, and we need to remember that one because it's a u of n formula.
Good.
Okay. And then let's continue. So it can help in many questions to use the fact that u of k plus 1, that u of k plus 1 is divided by u of k is u of k plus 2 divided by u of k plus 1, and all of that is r. So that's basically the next term divided by this term is the next term divided by the next term, which is r. So basically,
Brilliant, yeah.
The ratio.
So it's saying. Go on, you finish.
So the ratio of two terms is always the same, and that is r.
Good, yeah. So no matter where you are in the sequence, if you divide a term by its previous term, you always get the common ratio, which is r. Yeah, that's going to be useful for some questions where it's more algebraic if you're not given the term. So we might see examples like that. What about geometric series, Cordelia?
So for geometric series, then, wait 1 second. So for geometric series, what you need to do, then that's the sum of the terms of a geometric sequence. So the sum of the first n terms in a geometric sequence is given by S of n is a times 1 minus r to the power of n divided by 1 minus r. And by multiplying the top and bottom of the fraction by minus 1, we can also use S of n is a times r to the power of n minus 1 divided by r minus 1.
Good. And sometimes that just makes the using that second one just makes the maths a little bit easier.
Yeah.
If r
is
is
more than 1.
if r is bigger than 1, then it keeps the numbers positive, so it just makes the fraction a little bit easier. But the top one is the one that's given in the formula book and the one that's more common to see.
And also, the sum to infinity is actually just a divided by 1 minus r if r is less than between 0 and 1, because if it is, then that to the power of n, so if it's 0 between 0 to 1, then that to the power of n will definitely be 0. If n is infinity, then it's just a divided by 1 minus r.
Yeah, it converges to 0, doesn't it? Yeah, so if you scroll down a bit, there's some notes on it. So it says about there's the proof for that SN formula, but that's actually one of the questions that we're going to go through. So we won't do the proof right now, but we will do it in one of the questions because it can come up in exams, and we've got an exam question that goes through that proof. But as Cordelia was just saying, that when r is less than 1, i.e. the common ratio is, so not just less than 1, but between -1 and 1, the common ratio means that it's going to be you're timing by a number smaller than 1, so each term in the sequence is going to decrease. So the sequence will eventually converge, and that's because when you raise a number between -1 and 1 to a higher power, it gets smaller and smaller and converges to 0. So there is a sum to infinity, which is when, which of course we just spoke through, which is not given in the formula book, but you just need to remember that r to the n tends to 0 when r is small and n tends to infinity. And that gives us our sum to infinity.
Yeah. So,
what about a recurrence relation then, Cordelia? What's a recurrence relation?
A recurrence relation is simply another way of defining a sequence. With recurrence relations, each term is given as a function of the previous. For example, u of n plus 1 is u of n plus 4, and u of n is 1. U of 1 is 1. That's an arithmetic series with the first term 1 and the common difference 4. So what the first one's saying is that the next term will be this term plus 4, and what u of 1 is saying is that the first term is 1. So in order to generate a recurrence relation, you need to know the first term.
Good, yeah, it has to be defined, doesn't it? Otherwise you don't know where to start. Okay, and then finally the last little bit in our notes for sequence series is about sigma notation. So what do we mean by that?
So sigma notation is basically it basically means sum, and it says that you need to be comfortable solving problems where series are given in sigma notation. So sigma notation basically is just a way of saying a series, because a series is the sum of the terms of a sequence. So that's basically what the sigma notation does. So below is
brilliant. So
it
means that
explaining how it's used.
Yeah, brilliant. So it means the sum of. So if we read it, this example here, the sigma, we read as the sum.
It tells us our last value of r for our sequence. That means our last term will be 7 minus 2 times 20, which is minus 33. Excuse me. And this is the value of r where our series starts. That's r is 1. That means our first term is 7 minus 2 times 1, which is 5. And it says 7 minus 2r, so that's how we know the formula. Inputting r is 1 into this expression gives the first term, 5. Then 2, inputting 2 gives us the second term, and so on.
I didn't get that. Could you try again?
Not again.
Oh, Siri's interrupting us again.
Siri. 8, so...
Can you still hear me, Cordelia?
Yeah.
Yeah, perfect. Good. I wasn't sure whether it was cut out.
8. So, if you're ever troubled by... Wait, I forgot to answer. This series in particular, that one, represents an arithmetic series with the first term 5 and a common difference of -2. If you're ever troubled by a series given in sigma notation, it's a good idea to write out the first few terms and analyze the series that way. Okay, so
Okay.
guess we can move on to our first question.
Brilliant. So, question 1. Have you got it open? Yeah. So, question 1. A car has 6 forward gears. The fastest speed of the car is given in first gear is 28 kilometers per hour, and in gear is 115 kilometers per hour. Given that the fastest speed of the car in successive gears is modelled by an arithmetic sequence, find the fastest speed of the car in third gear. So quite common that sequence series, they tie in these modelling questions where they apply sequence series to real life questions. So for example, you get a lot of geometric sequences in sort of financial situations like compound interest comes up quite a lot in geometric series, but this is an interesting one about an arithmetic sequence and the speed of a car in its gears. So how would we find the fastest speed of the car in third gear, Cordelia?
What we would do is just that one. And so we know the first term, which is A, that's 28. We know the last term, 6, which is 115. Right? Now what we need to do is to find the common difference. That's L minus A divided by the number of terms.
Let's think about which formula we're using. You're right, but let's think about which formula we've just spoke about, which one you're going to use.
So I think we're going to use the U of N formula.
Yep.
Yeah. So then, yes. This will have to work out R. That's going to be 115 minus 28 divided by, is it 5 or 6? I think it's 5.
So think about it again. So we're doing an arithmetic sequence, Cordelia. So why would we be using R?
It's actually a
So what I would advise for any sequences series question is first of all write down the formula that you need. So it's one that's not given to us, it's one we have to remember, but it's UN equals A plus N minus 1 D. Okay, and you've told me that A is 28, good, and you've told me that L is 115, but rather than L, that's going to be what? Can we give that in terms of U rather than L? So A is 28, what's 115? That's going to be U.
U of 6.
U6, good.
Equals 215. And U of 1, that's A. And that's 28. Then u of 6 minus u of 1 divided by it's 5, which is 6 minus 1. That's going to give us 5 minus 28 divided by 5. That gives us 17.4 for the thingy. 1.
Yeah. So so we're not confusing anyone. Like you're using this formula that's L minus A over. You said it was over N, but remember it would actually be over N minus 1, and it is this UN formula rearranged. Yeah. So it's what you've done is you've substituted A is 28. U6 is 115. N is 6. And we're working out D. So we've got 115 equals 28 plus 5D. And then that's where the 115 take away 28 divided by 5 has come from. Yeah, just so we've explained that clearly.
Yeah. So and then we found out that was 17.4.
So yeah, that's a common difference, yeah.
So yes, we'll have to add 28 plus 2 times 17.4. And because 2 because it's third gear and 3 minus 1 is 2. So that would be 8, and then that times 2 is 34.8, then plus 28 is 62.8.
Great stuff, yeah, that's correct.
Then now let's do part B. Now it's modeled by a geometric sequence. That means that that formula is u of n equals to a times r to the power of n minus 1. Okay, and then and the n is 5, so
Well, we don't know R yet, do we? So let's use the information we've got first. So we can't put N as 5 just yet.
I mean, well, we already know that n is 5, and we already know that a is 28. So now we have to work out r. So AR. So maybe we should sub in 6 then.
Good, yeah.
Minus 1 equals u of 6 is that, which is 115. Then you have to work out, wait, a is 28.
Mark has said in the chat that because we keep saying series, that's why Siri keeps interrupting. Series sounds like, hey Siri.
Oh. Let's divide by 28. That's r to the power of 5 is, what's 115 divided by 28? It's still 115 divided by 28.
Yeah, you could probably leave it as a fraction, probably because it's going to be not a very nice decimal.
R is the 5th root of.
Yeah, so make sure you're explaining clearly that why are we taking the fifth root of that?
We're taking the fifth root because it's the power of 5, and so if we do the fifth root and then we'll get the answer. So that's 1.3265.
Good, yeah. So r is the fifth root of our 115 divided by 28, yeah. 1.3265.
Yeah. So now let's do the next question. Okay. So a geometric sequence has a common ratio r in the first term a. And given that r is not 1 and that a is not 0, then
Oh, have you moved on? Cordelia?
yeah.
Have you moved on to question 2? Is that
yeah,
what?
I guess it must have just went off. 1 second. It should be better now.
I think the video's seeing your OBS screen, but we didn't actually finish that part B.
There we go.
We didn't finish part B to that previous question, and for some reason it's on the next. The text has gone on the next slide.
R is 1.3265.
Yeah, so we found R as 1 equals 3.265, but what's the question asking for?
We want to work out the speed of it in 5th gear, then 28 times by r. We'll just keep it as r because they want to write 1.3265. That
Yeah, good. So
5 minus 1. Okay, that is 28 times y, that to power 4. That's 86.694.
good, excellent. Another way we could have done that bit is because we're told the top speed in the 6th gear and we want the top speed in the 5th gear because it's just the previous term, we could just divide the 6th term by r and get the 5th term. That would have worked well as well. I wouldn't have needed to do 1.3625 to the power of 4.
Yeah. So let's do question 2.
Okay, brilliant. So question 2, this is we said we were going to do this, that we're given the formula. So a geometric series is a common ratio r and first term a, and told that r is not 1 and a is not 0. We are asked to prove that SN formula. So we said we would do this.
So for part A, we have to prove that S of n is a times 1 minus r to the power of n divided by 1 minus r. So all we have to do is so I guess we can still use the U of n formula. U of n, that's n into and just zoom out. Okay, that's n into times by 2a. Right, and then 2 times 2 wait, I forgot. let's just have a bit of a look.
I think you're confusing it with the SN formula for an arithmetic sequence there. With over 2 times 2 over SN minus 1. We've got a geometric sequence, so we want a times r to the n minus 1.
Yeah, yes. So a r to n minus 1. Oops, I'm on the wrong question. A r to power of n minus 1. And then, now what we need to do is we're finding the sum, so AR.
So I think a good thing to do is to think about what start writing down the first few terms of SN. So let's write down the series SN, thinking about what the first term is, what the second term is, the third, and then like carrying it on. That's how we'd start off this proof, and it's how we'd start off the same proof if we were proving the sum of term arithmetic sequence as well. Is to write down what would be the terms in SN.
So the first term would be where n is 1, so then that would just be a. Then the second term is n is 2, a r to the power a times r. And the third term would be and then where n is 3, so a r squared. And then
and then maybe plus ... And then what's the last term?
The last term is a times r to power of, or just infinity.
It's not to infinity because we're finding the sum of n terms.
Oh, yes, then that's a r to power of n minus 1.
Good. I just wrote it underneath. You could say just because your face is going up on the screen, so I've just written it out underneath, so it's not being covered up. Okay, so we've got SN. Yeah, that's what we're trying to prove is that SN. We can take this formula, take that expression, and we can simplify it. Okay. So what do you think we could do to that?
I think we could take a factor of a.
We could, but we want to do something else first. We don't want to do that just yet. Okay. So yeah, we don't want to do that. So there's a trick, and there's a trick with the arithmetic one. Okay. And there's a trick with the geometric one. You need to know both of them because you could be asked to prove either result in your exams. This is a past exam question, okay, where you need to prove this result. So what you need to do with the trick for this one is to multiply everything by r.
Right, so then that would just.
Okay.
I guess that would just move up to make AR plus AR squared plus plus AR to power of n. I've written it just underneath its corresponding term.
Yeah, perfect. Okay, and that is RSN, isn't it? Because remember we've times the left hand side by r as well.
Wait 1 second. So I'm pretty sure what we can do is minus them, and then
Brilliant.
and so then that's 1 1 minus r, already looking like the sum formula, times s of n is, well, all of them just cancel out to make a minus a r to the power of n.
Brilliant. Yeah.
And that is a times 1 minus r to the power of n. Then we just divide by 1 minus r to get a times 1 minus r to the power of n divided by 1 minus r. Okay. Then for part B, given that s of 10 is 4 times s of 5, find the value of r. Okay.
So S of 10 is 4 times the value of S5. Find out.
So a times 5, 1 minus r to the power of 10 divided by 1 minus r equals to 4 times 1 minus is 4 times by a times 1 minus r to the power of 10, and that divided by 1, and divided by 1 minus r. Then we can divide, we can divide by a divided by 1 minus r to get 1 minus r to the power of 10 equals to 4 minus 4 r to the power of 5. So
Good. Just on that top line there, Cordelia, you've got, so you just, if I'm just reading it right, struggling to read it a little bit, so you've got a times 1 minus r to the 10 over 1 minus r, yeah?
Yeah,
And then 4 times a 1 minus r, is that should be a to the r to the 5, yeah, that's correct. Should be r to the 5 over 1 minus r, yeah.
1 second, I'm struggling to zoom out. There we go. Then you just have to find the value of r. Then r to the power of 10 is 4 r to the power of 5 minus 4. And then r to the power of 10 minus 4 r to the power of 5 is 4.
Tricky equation to solve. Can you spot anything that might help?
So we can do x is r to the power of 5 and then it turns into a quadratic.
Because it is a disguised quadratic, yeah, well done.
So x squared minus 4x minus 4 equals 0. And I'm just gonna see the solution in the calculator before, just to make sure that it actually makes sense. Yes, kind of does.
You made a mistake. I spotted a mistake there. Because you've got 1 minus r to the 10 equals 4 minus 4 r to the 5. And you've times through by negative 1, it looks like in the next. So you've got this, and then from the next line, it looks like you've just times through by negative 1. Or 1's disappeared.
I didn't times through by negative 1, I just did 1 minus both of them. I guess we can change that to a 5. Then, what is that? Yeah, 5. So that would actually be...
It'd be a 3, not a 5.
Yeah. But it's r to the power of 10 minus 1 is 4r to the power of 5 minus 4, and then we add 1 to make 3. Is 3 minus 3 is 0. Just gonna check. Minus 3.
Might want to scroll up a little bit as well. It's not capturing in the bottom of the screen on the stream.
Okay. Still seems to be not working. What name? It says find the exact value of r, so I guess it must be something squared.
It might not be a square root, but think of maybe let's just solve that quadratic as we would. It solves quite easily.
I got the solutions as 2 plus root 7 and 2 minus root 7. So not
It's because
sure.
you've got the sign wrong.
Oh yeah, plus 3.
To be r to the 10 minus 4r to the 5 equals negative 3, and then it becomes plus 3.
Yeah. So then, yes. I guess x minus 3 times x minus 1. That is 0. X is 3 and 1. And there's supposed to be... Wait, there's supposed to be just one value, so if r was 1, then
What would happen if r was 1?
then it would just be divided by 0. Because
Good, yeah, it wouldn't be a geometric series, would it? It would be, well, it would just be a constant series, wouldn't it, if the common ratio is 1, and it specifically says in the question r is not 1.
Yeah. Then
So x is 3.
And so r is the 5th root of that, which is...
Brilliant.
The 5th root of 3
Is the exact form, so root 1 3, so we stop there. It's the exact value of our 5th root of 3, it's spot on.
5th root of 3. Then let's get to the next question.
Yeah, our third question is a nice question that has sigma notation and recurrence relations in there. So the first part, it's asking us to show that sigma of 3 plus 5r plus 2 to the r between 1 and 16, so the sum of 3 plus 5r plus 2 to the r from the first term to the 16th term, is 131,798. Do that first.
So 3 plus 5r plus 2 to the power of r, we can separate that into 2. So it's 3 plus 5r 1 to r 2 16. 3 plus 5r plus sum from 1 to 16 of 2 to the power of r. Okay. Then I'm not sure if we really can make it say that 13179. Oh wait, I thought R was the ratio thingy, so it was D. So
no, it's weird that they use R in the sigma notation, but no, it's not common ratio.
Yeah.
Not that R. It's weird that we're going to have to use 2 R's, but just a convention. So you're perfect so far. Splitting it up. Let's think about the 3 plus 5R first.
Okay, so the thingy was it was n into times my 2a something. So by 2a plus n minus 1d.
Yeah. So a good advice to anyone answering these sort of questions with sigma notation is to write out the first few terms in the sequence. So you've recognised straight away, Cordelia, that 3 plus 5r is just an arithmetic sequence. But it's easy to check by substituting in r equals 1, 2 and 3 to get 8 plus 13 plus 18 to see that it definitely is an arithmetic sequence.
Yeah.
So that's why we can use that you've written down there for the 3 plus 5r part.
And then what we can do from that is just n is 16, so that's 8 times.
Good, so we've got n equals 16.
And then r is 1, so 3 plus 5 times 1 is 8, so 16 plus, then n minus 1, 16 minus 1 is 15, then d is 5, so 15 times 5. And that is also 16 plus 15 times 5 is times 8, 728.
Good. So this 3 plus 5r part summed from the first to the 16th term, 728. Good. And then we've got this 2 to the r part as well.
Then the 2 to the power of r part. So the sum for that is just it was a times by 1 minus r minus r to the power of n divided by 1 minus r, and then that is so r is the power of 1, which is 2, and n is 16. So 2 times 1 minus, and r is 2 to the power of 16 divided by 1 minus r, that's 1, that's 1 minus 2, that's minus 1. That is, where is it? 2, 3, 1. And then that is 131070.
You should have been able to do that in your head quarterly. You should know the 2 to the power of 17. I'm only joking.
Then 728 plus 131070. Then that plus 728. All that is plus 728. And that's 131798. Is that what we've got? What the
Yeah, that's exactly right.
131798. So, challenge question.
Oh, part B. There's a part B to that previous one. Jumping the gun.
Okay. Then part B.
So we've got a recurrence relation. UN equals 1. So UN plus 1 equals U1 over UN. And we're told U1 equals 2/3. We want to find the exact value of sigma UR from the first to the 100th term.
I guess that's periodic because it's just going to be 2/3, then 3 over 2, then 2/3, then 3 over 2, then 2/3, then 3 over 2, then 2/3, then keep
Brilliant,
going.
yes.
So that's periodic with order 2. Okay, so then I guess what we can do is just there's going to be 50 times the sum of the two, that's the periodic in, 2/3 plus 3 over 2. Well, that is 50 times by 2 in 3 times 3 in 2 is equal to 108 point and a third.
108 and a third, yeah, exactly right. 325 over 3. Fantastic, yeah. So it's periodic, order 2. So you're going to have 52/3 and 3.5, and yeah, so 50 times 2/3 plus 3 over 2. Brilliant.
Right. Second list.
So the challenge question, not quite as difficult as our partial fractions question last week, I don't think, but still a good challenge. Have you got the challenge question up here?
Yeah.
Yeah. So a factory gets permission to dispose at the start of every day 600 kilograms of waste stream of water. How dare they? The running stream removes 40% of any of the waste present. 40% of any waste present? That's terrible English. 40% of any of the waste present by the end of the day. Determine a simplified expression for the amount of waste present in the stream at the nth day.
So
So
yes, it keeps multiplying by 60% because 40% just get removed. So R is 0.6.
it's tricky on this one. Don't rush into things too quickly on this one.
At the start of every day, 600 kilograms of weight. Into a stream of water. Okay, so then it starts at 600. Yes. So 600 of it goes and it removes 40% of them, so 0.4 times 600 is that's 240. So it's every day it's 240. So I guess that's actually periodic with order 1.
Well, it's not because, well,
because actually it's 240, and then at the end of the next day it's 480. So it's actually a series, but
it is a series. So let's think about what's happening first. Okay, what I want you to do is write an expression for un plus 1. Just think about for the formal recurrence relation, which gives the amount of waste at the end of the day, the end of the nth day. So how much waste was in the previous day? Where un is the waste amount of waste from the previous day.
Okay, so it's not very. It's 600 kilograms. 40%. It's actually 0.
So however much waste is in at the start of the 600 kg extra is added at the start of the day. And then by the end of the day, 40% is then taken out. So how could I write that in terms of a recurrence relation?
Yeah, because it's 6. Yes. Wait a second. So that's 600 times 600 times by 0.6. That's 360. So 360 plus then 600 kilograms times 0.6. That's 0.6. Wait. Times by u of n.
Brilliant. Yeah. Okay. So our recurrence relation is 360 plus. So just to make clear what you did there, you did un plus 1 is our the amount that was in the nth day, un plus 600. That's how much has been added at the start of the day, but by the end of the day, 40% is taken out. So you're timing that by 0.6. Okay, so that gives you 360 plus 0.6 un. Okay, so that's our recurrence relation. So with like the previous question, and any sort of sigma or maybe recurrence relation question, what I would advise is to look for a path start working out some terms. Okay.
Yep, so then that's u of 1 is just, and also we know that u of 1 equals, we know that u of 1 is 360. Wait. One second. So we already know that u of 1 is 360 because u of 0 is just 0.
Good, yeah, so that's how much will be in the stream at the end of the first day. 360 kg of waste.
And 360 plus 0.6 times 360. 570.
Don't worry about working it out. Let's just leave it like that. 360. I want you to write that down. 360 plus 0.6 times 360 because it will help with spotting a pattern.
I think I've already spotted it. Let's just make sure. Okay, and then I'm going to calculate it and then write equals and then the expression.
Okay.
So then that times 6 plus 360, 705.6.
Yeah, so this question is slightly harder than you might expect to see in an actual A-level paper, but it's a good challenge question. It doesn't rely on any knowledge further than A-level maths, so it's a good challenge, a good sort of extension question to do. And ones similar to this do come up. This one's just slightly more difficult. But a good trick is to write down the calculations and see if you can spot a pattern, because you might fall into the trap of trying to find a arithmetic or geometric series in just our nth term. In just our terms, it doesn't actually work like that.
This, and then 360 plus 0.6 times 360, that's 0.6 squared times 360. So yes, it's, and then it's just going
so you got U3 is 360 plus 0.6 times 360 plus 0.6 squared times 360. So just what do you think U4 is going to be?
Just 360 plus 0.6 times 360 plus 0.6 squared times 360 plus 0.6 cubed times 360.
Brilliant. Let me just write that down, and while I write that down, you can think about how you generalise that for UN then.
So yes, then U of n would just be 360 plus 0.6 times by the power of 1 times 360 plus and dot plus 0.6 to the power of n and minus 1 times 360.
Okay, so you're right, yeah, UN equals 360. That's 0.6 times 360 plus plus 0.6 to the n minus 1 times 360.
Yeah. So
and then what could we do with that?
And,
so if you carry on from my working up, if you go down a little bit, so you see that I've written UN out, then you can do my working out from there.
Okay, so we want to find the simplified expression for the amount of waste present in the stream at the end of the nth day. And I guess to simplify it, it would just be equals 360 times 1 plus 0.6 plus 0.6 squared plus dot dot dot. And actually,
But it's not an infinite. When you do plus dot 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 and then don't end it, that implies that it's an infinite series, but it's not an infinite series because we've got an n on the end. It's un. It's a finite series.
yeah. So,
Good, well done.
So then we already figured out that was just a times by 1 minus r, that's 0.6 to the power of n minus 1 divided by 1 minus 0.6. Then 0.6 is 1 minus 0.6 is just 0.4. And a is just 360. And it is, and I guess it's been finished.
Oh, can we simplify that there? And actually, when you're using, remember the formula for Sn is a bracket 1 minus r to the n over 1 minus r. It's 1 minus r, it's r to the n minus 1 in un, but it's r to the n in Sn. And we can simplify that further.
360 divided by 0.4, well that is 900. 900 minus 1 minus 0.6 to the power of n. Wait, no, not minus, 900 times that.
Brilliant, yeah. So un is 900 lots of 1 minus 0.6 to the n. Yeah, exactly right. Well done, Cordelia. Spot on.
So I guess we've finished the session. Thanks for watching, viewers.
Thanks for watching. If you have any questions or want us to cover any other topics in these sessions, just drop a comment and make sure you visit thedeciphers.org. Like and subscribe.
Yeah.
See you next time.